thin gas will absorb that cool, thin gas will absorb, or I like to say, it's Thanksgiving anyway, those same frequencies it glows when hot. So in other words, if I take a gas tube and I shine all the light from a light bulb or whatever through it, there's going to be some missing lines. Missing, or if you will, dark lines. So let me do Roy G. Biv. What's this? That's reds. Orange, yellows, greens. Shine a rainbow, shine white light through it. Blues and violets. And if I shine it through this same gas, which colors will it absorb?
The brighter
Those
colors?
exactly, those same ones. That was going to be in here somewhere, really. And this guy's over, whatever. These are the missing lines, or the dark. Frequencies. So, if it's cool, it'll absorb those frequencies, and if it's hot, it'll glow those frequencies. Everybody okay with that? Let's finish writing our notes and then show it, because it's fun and we can do this just in time. Dark missing, so this gives dark missing line spectra it's called absorption spectra. Absorption spectra. And this happens in the cooler outer gas of the star. The star shines all this continuous range, and it goes through, and what you find is missing, and it is a big mess. And thank goodness for computers, because man, it is a mess. Can't even believe people like Annie County can go through this out. So that's it. You look at the lines. Now I'm going to show that to you right now. It's so cool. Now I'm going to do it. I know it's not as much fun, but I'm going to try not to shock myself. I shocked myself once before. These old things are not good. So here's going to be gas. You're going to look at it with your diffraction grating. But first, do everything with your eyes first. It's not plugged in, right? Okay, good. That's how I shocked myself the first time. Okay. Maybe like tense up right across your heart, right here, you know, and then swear involuntarily. Now my colleague did it with this one. That's worse. Felt for a week, and he threw the glass cube across the room and all that stuff.
You should do it.
Yeah, thanks. Thanks, good. So, what color is the middle part to your eye?
Pink.
Pink. I'd say pink. So it's pink. But now, use your diffraction grating, and let's
Too many lights.
Let's get rid of this. We don't need you. Look at it and see what colors, because you know your eye sees this combination of colors, but in fact,
It's skin color. There's gas. There's hell in it.
So first you look at your
There's only a few lines, right?
Blue,
Because
red,
this
and
is a
violet.
hot, thin gas.
Red, and violet.
Sorry. I'm doing this. I'm sorry. I want to see too.
Blue, red, and
So rotate over. Now you got to rotate the farther you way. You might have to rotate way over to the side till you see. Don't worry about the fuzzy. There's a bright red, right? Then there's a bright red. There's like a turquoise and a violet. And there may be another violet way over there.
Yeah, there is.
Right?
Yeah,
Wow, that's very beautiful.
Now,
I see like a
check this out.
violet, red,
Now that happens to be the most abundant gas in the universe. The atom, what is that? What's the most common atom in the universe?
Oxygen.
No. Simplest atom.
Carbon.
Hydrogen.
Hydrogen.
Now, if I shine all the light through it, what do you think it will eat or absorb? What colors? Those exact colors.
So now
The colors that it glows when it's bright, it will absorb when it's cool. And this is more like how a star works. The hot one sends out all this continual range. It goes through the cooler atmosphere. The cooler atmosphere eats some of those, and we analyze it. It's really confusing because you have lots of different atoms, and it's really a big mess, and you really have to use good equipment to sort it out. But you can do it. Now, if I take this one, and I know, this is. Now I'm going to put, oh no, seriously? All right. For some reason it's missing. Okay, well, no, I was going to do hydrogen. I was going to do a gas, and you look at it and you go, hey, that looks just like that. And you go, hey, that has to be hydrogen because no other gas flows that way. Okay, pretend we did that. So now look at this one. So now look at this gas. We'll get rid of, you're unplugged, right? Okay. Here. So what we do is we line up the lines and do this. People looked at this for a long time. Please unmute. Okay, good. And now I will plug in. This is a different kind of gas. Do you think it'll give the same colors?
Yes.
It'll give the same colors. It always gives, but it'll be different than hydrogen. And I can do this. I know I can. Okay. Oh, it looks kind of white, but maybe a little yellow. A little yellow, right?
Holy shit, it glows yellow.
What? Oh, look how bright that yellow is. You see it?
Red, yellow, green.
What else? What star do you know that looks kind of yellow?
Sun.
Sun. And guess what this gas is?
Sun.
It's named. What's another name? That was good. What's another name? Helios. It's helium.
I'm so smart.
It's helium. That's helium. Now what? Now, what colors will it absorb?
All of it.
Those exact colors. Now we get rid of this. And we look, I just have a few. But how about krypton? What color should krypton
Green.
glow?
Green.
It should glow green, right? I mean, Superman and everything. Krypton's a kind of gas. Look at it with your eyes. Look at it with your eyes. And, oh, that is so boring. But wait. Look at it with your diffraction grating.
Oh yeah, that is kind of boring.
Orange, green, and
You got krypton green. Yay. But that combination,
Oh, what about orange and orange?
yeah.
I don't see the other
I see a small.
You see the green?
Yeah.
I see green and a little,
I see
The yellow?
and the yellow. That's it.
And go
I
over to
see
the
a
red.
Little red, orange, green, yellow.
Oh, yeah.
That's krypton. And only krypton glows those colors. When it's cool, it'll eat those colors and absorb them. Now, I better not do this too fast. It's how I get shot.
Don't hurt yourself.
Now, take a look at this one with your eye. Because I'm going to compare the next two. We only have a couple more.
Lightsaber.
We could do a lot more, but you can go on YouTube in this. But the point is, we can tell the kind of atom by the light it glows or absorbs. Here it goes. Take a look with your eye. It is. Ooh, I love that color.
Lightsaber color.
Now look. It is a mess.
Wow.
It's a mess because it's carbon dioxide. It's carbon with 2 oxygen, and it's just complicated, and thank goodness for computers.
You can almost see a gap.
Yeah, it's kind of, now watch that, look at that color. Here we go, that was carbon dioxide gas.
Wait.
Molecules are more complicated. Now look at this one.
Is it
First with your eyes, because you'll notice something with your eyes. Comparing it to carbon dioxide, it looks similar. But now look,
Oh,
Say I see blue, green, and
much simpler because this is just it's mercury.
Mercury?
Stuff they use for fluorescent light bulbs.
it looks orange to me.
Orange.
And that's mercury.
Yeah.
I mean, the brightest is green.
Yeah, I'd go with that green. I'd go with that green. Now, but this, by the way, you can't use the brightest one here. It's a different physics here, a different relationship. What this is telling you is what is there. And when you shine all the colors, it'll eat those same colors. One last thing, what do you call the old signs that were made of glowing light with gas in them, thin gas? Neon lights. What color is neon? Now you could add, all you need to do is add little bits of these other gases and you get other colors.
Neon orange, neon yellow, neon
What
green.
were the first glowing gases?
Yellow and green.
Yellow and green. It wasn't?
It was yellow, I know.
Now I'm going to draw a connection.
It was a highlighter.
Ready?
That's
Oh, red or
What
orange.
is this?
Check that. This is
I've
neon.
never seen that.
Holy there's a lot of red and orange and yellow.
Right? And that combination. Now watch.
And it's like one green.
This is the
One
punchline.
green?
This is the punchline. This is a thin gas. When it's hot, neon will glow those colors. When it's cool, it'll absorb those colors if they're shined through it. This, however, also looked the same color, didn't it?
Yeah.
And you saw green, but it's different physics. And so this is a hot solid. With this one, you could pick out the brightest one and tell the temperature. With this one, you look at it and you can figure out what frequencies are there and use that fingerprint to identify you've got neon, which is made in stars. And so we'll talk about that stuff, finish this up next time. And thanks guys, that was fun. I hope you guys have a great Thanksgiving. I know